Thank you so much for having me and giving us the opportunity to present this project with you. Magnuson Architecture and Planning is a mission-driven firm, meaning we support the mission of our clients to provide healthy, safe, and affordable housing and create vibrant communities. Over the past 30 years, we've been a part of the active growth in sustainable, healthy, and energy efficient architecture, which we believe is central to supporting our clients' missions. Today, I'd like to share with you Cooper Park Building 2, which is a new affordable multifamily building that is one of our 7 NYSERDA Buildings of Excellence projects and starts construction this year. Cooper Park Building 2 is part of a larger industry trend. MAP is working to provide near net zero projects through a carbon comprehensive lens across our entire portfolio. We know they provide a better quality of life for our residents and more durable and efficient buildings for our owners, and contributes to our collective societal requirements. We are tracking this effort, which you can see in this approximately 10-year plot of all of our projects' source EUIs, with our Buildings of Excellence projects highlighted. We can see that these projects are part of an industry-wide shift towards a healthier standard that we believe will become the norm very soon. Literally, the core of the shift to a new normal is towards healthier architecture, healthier for the occupants, but also for the neighborhood, for those creating the materials, and for the environment. Here is a summary of the central principles of our approach versus code minimum on the right. The Passive House community will be very familiar with these principles. The key to making this work is that these principles work in tandem with each other. So if one element is not fully implemented, the rest will either not work or not work as well. Therefore, resources spent on one will make others less costly to achieve. Our buildings are designed as whole systems working together in order to really take advantage of these co-benefits. You will see these central ideas working together in this project example. Cooper Park campus is the former site of Greenpoint Hospital in Brooklyn, which was decommissioned in 1982. In the years since then, there have been many attempts to redevelop this 5-acre property. Currently on site is a smaller building containing the headquarters of St. Nick's Alliance in the southeast corner. There's 5 other vacant buildings and large outdoor spaces that are currently fenced off to the public. You can see the historic abandoned main hospital building in the center with the copper roof. A team consisting of Hudson Companies, Project Renewal, and St. Nick's Alliance have crafted a development plan known as Cooper Park Commons that achieved large-scale redevelopment zoning approval last year. Actually, the year before last year at this point. Architecture Outfit is our partner architect, who also focused heavily on the exterior design and interior common space design, and who created all of the renderings I'm about to share with you. The total project will retrofit 3 buildings and construct 2 new buildings, one of which will be an 18-story passive house tower known as Cooper Park Commons Building 2, which is the focus of this presentation and sits in the center and front of this image. The entire site redevelopment creates 557 units of affordable housing across 3 buildings, of which 110 will be affordable senior housing, and renovates a 200-bed homeless shelter and will contain a health clinic. There will also be retail and community facility space. The design seeks to integrate the property into the community. The public will be able to access much of the site. The rezoning and redevelopment plan went through many rounds of city planning and community input, which resulted in some specific design moves. One is to maintain views of the main historic hospital building in the center here as much as possible. So you can see our building, Cooper Park 2, steps back to widen the view corridor there. Also from the entrance off of Maspeth into the lobby of the building, you can see straight through to the historic structure. Additionally, much of the site is landscaped now and will be landscaped and publicly accessible. For example, Skillman Avenue in the center there is a fire department access road, but it will be landscaped to promote pedestrian use only and discourage no more vehicle traffic. Here you can see a view of Skillman Avenue showing the planned renovation of the hospital building on the right and building 2 on the left. The massing corresponds to the context with setbacks and material variations. This is a rendering of the lobby, showing a bit how you can see through the lobby to the historic building in the center of the campus. Cooper Park Building 2 is a NYSERDA Buildings of Excellence Round 2 winner and won a blue ribbon for design. The building is 18 stories and will create 311 units, all of which are designed as affordable housing. Currently, we're in the latter stages of construction documents. The building is all electric, with the exception of the required emergency generator, and is planned to be PHI certified and at a minimum, LEED Gold certified. Here you can see its site and source EUI as it compared to code minimum and Passive House EUI requirements and its projected carbon emissions compared to local law 97 limits. Just by the nature of baseline affordable housing, which is required by HPD in New York City, many prerequisites for this project are already met for LEED version 4. And some points are relatively simple to achieve and document. This project is aiming for 76 points, but most certainly can achieve a few more that are pretty straightforward for our typology and almost code minimum. Code and regulations in New York City are really catching up, especially for projects receiving public funds. This is a recognition of the benefits of building this way, as it is a smart return on investment and a good stewardship of public dollars. If you're curious with how Passive House interfaces with LEED, LEED allows for Passive House certification to satisfy its annual energy use credit and gets you a certain number of set points, but you can't get all of the 37 points available in the energy and atmosphere category just by going with Passive House. Also, you can provide a LEED project without ERVs. It's an optional credit, but we strongly advise all of our clients to provide ERVs throughout all habitable spaces in order to actually provide fresh air. Here's a summary of the core sustainability measures for this building. This is a more detailed view of the core new normal principles I mentioned earlier. Before I get into the specifics of the robust enclosure, all electric systems, filter fresh air, and healthy materials, we can walk through the plans of the building so you can orient yourself. So you can see we have a partial cellar here, which saves on costs. We mostly have our mechanical entry points here as this building is not in a flood zone. And the bike storage is down here in the lower left-hand corner. Here on the ground floor, you can see the entry lobby in the center with a large storefront on the facing elevation towards the historic building to the north. There are retail and community facility spaces at this ground floor and the supers apartment. These community facility spaces are within the Passive House envelope, but there's an air barrier between them and the rest of the building, as they won't be part of the Passive House certification itself. Here is a typical lower floor. The units are stacked as much as possible to improve system efficiency. And you can see on the left-hand side of the plan, the trash room here contains 2 chutes. Many of our projects now are incorporating 2 of them to ease the collection of recyclables. Department of Sanitation in New York has started requiring, as of last year in the spring, waste management plans for buildings with more than 150 units. And this is an important piece of that plan. We have been watching closely policy developments in this area and are anticipating the return of the composting program as well as on the horizon. This is a critical aspect of modern living that we really need to get right. How do we manage what we discard in order to really reach a circular economy? On the setback terrace, we have a community room, which is connected to the outdoor recreation space in the middle volume. And on the right, you can see the roof for the lower floors and the condenser units for the split VRF system that line the perimeter of the building, which keeps refrigerant distribution inside the building really efficient. And then, of course, there are the ERVs that are relatively centrally located as they collect all of the ducts from the shafts below. So here's a typical floor going up with the unit stacking, and then the roof for the tower. Again, the same concept of the mechanical layout up here, and then there's a generator in the lower side of the plan. So now we'll get into an overview of the thermal enclosure, which is in Passive House, as most people know, the key to right sizing the mechanical system. Engineers can now rely on a virtually zero air infiltration in their load calculations, which is a key number in those equations. There are two types of cladding. Both will be site-built construction. The bottom is brick, and the top was originally glass fiber reinforced concrete. But for cost reasons, the team is considering a custom porcelain panel. We are also reviewing to confirm if this is an improved embodied carbon choice. Thermally broken girt, such as green girt or night wall, will be used to create continuous insulation. The windows are triple pane, and we have R16 mineral wool at the walls. Together with our partner architects, Architecture Outfit, we reviewed a number of brick detailing options. In the rendered section, you can see the window surround brick detail extends beyond the main brick face. However, the current iteration does the opposite, recesses the window surround as seen in the jamb detail. The base building facade system is a fairly standard backup wall with air and vapor barrier at the sheathing, continuous exterior insulation at R16, air gap, and then a standard 4-inch brick veneer. However, at the window jamb, the developer didn't want to see a metal trim cover the insulation and air gap, as you see would be created at the jamb, which we typically provide this sort of metal cover in our modern in the new construction today. But they wanted instead the aesthetic of a more classic brick return. So based on the size of the building, we have the economy of scale to be able to order a custom brick for all of these jambs that we'll need, which allows us to avoid complications of supporting these jamb bricks desired over the air insulation space below, while still providing continuous insulation at the window. Because we have a dense building here with really good form factor, we don't need more insulation in the studs of the wall. So the detail that you're looking at here is correct. We only have exterior insulation outboard of the structure of R16. So now I'll dive into the building system for this project. I'm sure everyone is familiar with heat pump technology. It's around 3 times more efficient than fossil fuel fired equipment will ever be, and it works at very cold temperatures. This building is using floor mounted indoor units instead of the more typical wall cassettes or ceiling mounted units, as a decision made by the development team because they felt it had a more residential aesthetic similar to a PTAC, but smaller. This one is only 9 inches deep and of course doesn't have any louvers on the facade. Because of this building's tall height, we coordinated additional refrigerant risers to allow for a lower, middle, and upper zone in the system. This results in 6 risers at the upper floors, which reduce in number as the supply and return extends down the building. Cooper Park is incorporating a vertical distribution of refrigerant, as mentioned before when we walked through the plans. They're zoned per facade to provide comfort. So the units will be in either heating or cooling mode and not both at the same time based on facade exposure. This avoids horizontal distribution or a heat recovery setup, which would allow for heating and cooling at the same time, but uses massively more refrigerant and places refrigerant in enclosed ceilings, horizontal distribution, where it's difficult to find them again. This diagram is from another project, but it shows just how much refrigerant is really saved in a non-heat recovery scenario. Given the fact that refrigerant has a very high global warming potential, some of the ones currently being constructed, but there are new ones in development, but the ones being used now are several times more global warming potential than CO2. So we want to reduce the risk of leaks as much as possible. We believe we can achieve the same level of comfort without heat recovery and significantly lower the amount of refrigerant lines, which of course keeps costs down too. Refrigerant can leak at fitted connections, which are all built on site, so brazed and flared copper connections. It's important to follow through with quality control procedures to construct and then charge these lines. Two other critical quality control concepts are to provide access panels at connections and ensure that the owner is provided with a documented record of the amount of refrigerant in each line based on as-built calculations of refrigerant lengths and the charging amount during final testing and commissioning. So now we'll touch upon ventilation. Cooper Park is using a centralized ventilation system. The decision to use a system instead of unitized ERVs at each apartment with ducting to the exterior walls was intentionally based on aesthetics at first, removing louvers from the facade, which additionally reduces penetrations in the thermal envelope, making it simpler to meet our passive house goals. But the GC was concerned with the additional cost of vertical shafts, so we conducted a cost comparison. Since the area under the horizontal ductwork inside apartments' habitable space would have been lower than 8 feet, it cannot be counted towards HBD compliant unit area, which is slightly larger than code minimum. So we had to include in the cost estimate raising each floor by 4 inches or 8 inches. In a central scenario, only the floors, central ventilation scenario, only the floors under the roofs need additional height to collect the ducts and bring them up to the units. In the mechanical plan here, you can see on the 12th floor ductwork, the right, you can see all the ducts collecting to meet the equipment on the roof directly above. And on the left side of the plan, the risers continue to the roof unit on the top of the tower. Other important considerations in ventilation are making sure you're using high quality filters. So we use MERV 13 or better, and using car dampers, which keeps the airflow balanced in a large building, especially important with a lot of stack effect, and making sure you have really good air sealing in your shafts. So we use a product that seals them after they're constructed from the inside. So here I'd like to emphasize how critical it is to provide dedicated fresh air to each habitable space through an ERV or an HRV. We are getting more data about how code minimum ventilation is really not providing true air changes or fresh air, even with current energy code minimum air tightness. An example of this dangerous result is CO2 building up at night. Here's the results from one study showing how often it reaches above 1,000 parts per million. Unless we are providing dedicated fresh air that is balanced between supply and exhaust, the building is not achieving real air changes. It's difficult to measure this, but there are a number of studies available to demonstrate it. There is a much higher risk for condensation issues and high CO2 levels, or a buildup of many other toxins. Building codes are progressing towards requiring intentionally supplying fresh air to all habitable spaces, just as sprinklers became baseline not too long ago. In fact, in the International Energy Conservation Code of 2021, ERVs are required in multifamily buildings. Ventilation can be considered a life safety issue in many ways if you consider the implications on health. So when constructing an all-electric building, laundry equipment, shifting a bit here now, is also an important factor. Typically, our affordable housing developer partners rent the laundry equipment from a vendor who also services them. Unfortunately, right now, there are no vendors in New York City that we know of so far that provide heat pump dryers. This is unfortunate because heat pump systems will save significant energy. On another project, for example, that's a difference of about 7,400 kilowatt hours per year. And it also increased cooling demand because of the internal load from the electric resistance dryers. So we anticipate the laundry industry will be catching up with the all-electric progress we're making. Integrating solar PVs is another important part of building-wide electrification. It's a good investment with an excellent payback, and many incentive programs are available to subsidize installation costs. In fact, we're seeing systems being priced today with a payback of 3 to 4 years. We are also hearing that the city is looking at adjusting zoning rules slightly to allow for more solar to cover rooftops, hopefully being announced this year through the Zone for Zero Carbon. However, right now, any solar that is above a building's height limit can only cover 25% of the top roof area. Cooper Park was able to avoid this zoning issue because the building is part of a large-scale rezoning through the city ULURP process. The rezoning increased the allowable floor area, but the large-scale development allowed for waivers to the bulk height and setback requirements beyond the upzoning, which increased the allowable building envelope to allow solar to be within that envelope and therefore not limited to classifying it as a permitted obstruction, which then would require it to be only 25%. Currently, the building has a gas-fired backup generator. Residential buildings over 125 feet require this backup power for life safety elements such as the elevator, fire pump, and emergency lighting. Unfortunately, the easiest and most economical solution at the moment is a gas generator. We have looked into battery backup power, which could draw from our solar panel arrays. But currently, the amount of battery power that would be needed to accommodate the startup loads of the elevators and fire pumps would require far more space than is typically available, and is prohibitively costly at the moment. However, we are looking at batteries on other projects where the grid is constrained, and the value proposition changes at that point because these batteries can help shave off peak demand if connected to the grid. On this building, through the Buildings of Excellence Award, the team is reviewing the option to add an automatic transfer switch to this emergency generator that would allow additional, although not required, convenience electrical loads to be added to the generator without increasing the size of the generator. So currently this option would add electrical outlets and heating and cooling equipment to the double height entry lobby and lounge at the ground floor, which you can see here. So the last piece of the puzzle is what we build all of this with. As an industry, we are now truly discussing embodied carbon, which is imperative. Embodied carbon is the primary focus because minimizing emissions over the next 9 years or so, maybe 8, are critical to backing us off of climate tipping points. In a business as usual scenario, embodied carbon would account for half of new construction emissions between now and 2050. So here are the current central strategies we're thinking about as a firm when we look to reduce a project's embodied carbon. We believe there is a lot of immediate low-hanging fruit in this area so that we can target to reduce embodied carbon from our projects about 20 to 30% with negligible impact on costs. So please check out this study by RMI for more examples. For one particular project, we studied this climate tipping point or 10-year timeframe very carefully and calculated the balance of the carbon impact of a material investment for its operational carbon savings versus the embodied carbon spent upfront on that material. We actually found, for example, that we didn't need to spend a large amount of embodied carbon on roof insulation as we had previously thought, because the additional thickness saved very little on operational energy. This is a good example of being able to rely on rules of thumb during design, but allowing yourself the time to model and test them with your actual project parameters once you're far along enough, especially with our climate emergency in mind. So here are some standard measures that we pursue on our current projects. For this project, we are doing most of these, which include 50% recycled local aggregate, 90% pre-consumer recycled content for the drywall. Construction waste is at a minimum 75% diverted, stone wool insulation on our walls, and calling for environmental product declarations in all of our specs. Most of the lead points associated with embodied carbon are in this credit for environmentally preferable products. You can see the criteria on the left requires 90% of a certain material in the project to contain these highlighted values. And then this project's targeted points are shown on the right. You can really save significant embodied carbon by adding it to your list of material performance requirements while you're doing your research for the project. The healthy materials measures that this project is performing is essentially these central ideas on the left of the slide. So 90% of our floor covering is floor score certified. It was originally bamboo, but it was VE to LVT, which is a difficult material, but there are floor score certified versions that do have a little bit of a benefit. We have Green Guard Gold certified insulation, no urea formaldehyde, and low VOC paints and sealants. But we have a long way to go as an industry on this front, similar to embodied carbon. And these two issues are very much interrelated. There are over 85,000 chemicals in our modern day society, and only 200 or so have been tested for their toxicity, and about only 8 are regulated by the EPA. The field of green chemistry is only a few decades old. Their principles are on the right of the slide. It's a revolutionary concept to business as usual, where chemists test first if their inventions are safe before implementing them. So additionally, this project might seek the certification for the points from LEED to do a 48-hour flush of the buildings with the HVAC system off and all of the doors open. I cannot pass up the opportunity to mention another embodied carbon topic, which is particularly about plastic. I've had many conversations with sustainability professionals, particularly ones focused on energy efficiency, who are not yet aware that plastic production and disposal contributes massively to greenhouse gas emissions. The connection between embodied carbon of this material in particular to climate change is not well internalized or talked about. Plastic releases an enormous amount of toxins throughout all stages of its life cycle, and the real impacts of this are really just beginning to be understood. It's a significant source of greenhouse emissions in the US, and the petrochemical industry's plastic infrastructure is rapidly expanding. The health impacts of emissions released are disproportionately felt by low-income communities. And the superabundance of fracked gas in the US has turned the US into a global engine of plastics production. Polyethylene, which is about 36% of all plastics in existence, releases greenhouse gases such as methane and ethane more than any other plastics, and it's lightweight, so it floats to the surface of the ocean, allowing it to release these even faster. This is a kind of snips from this report shown in the previous sourced in the previous slide. Each smokestack here is CO2 emissions from one 500 megawatt coal-fired plant in 2020. There's talk about chemical recycling from the plastic industry, which has more in common with incinerating than recycling and releases a lot of pollution. You know, I'll be very honest, plastic is a very useful material. I think we need to find a way to be making it, reusing it in a more responsible way, and do that testing to make sure that our formulations are safe and have a circular story before we release them. It's difficult. I think the plastic industry has been trying since the first concept of recycling came out, but really only 1 or 2% is recycled into something equally as good as it was before. There isn't a clear answer how to address this issue. So we should probably at first stop using throwaway plastics, or in other words, fake recycling it. So back to this project, which we are extremely excited to start construction on this year. So this is a view from the main street looking towards the hospital building, a view of the lobby entrance, and some other wonderful images for you. We anticipate construction to take about 30 months, and we're optimistic it'll stay on schedule. Hudson Companies has a partnership with the GC called Broadway Builders, and they have been advising us on materials that we should consider as alternatives because they've seen issues with reliability or availability and cost. The Hudson Companies, the developer, is prioritizing building to the Passive House standard and has encouraged several members of the GC team to also become Passive House certified installers. And So the whole team is becoming more and more experienced, and we anticipate that that will lead to an even greater successful project. Well, thank you for your time, and I look forward to working with all of you in this on this work together.